Okay, we're moving on to lesson 3, slope-intercept form. We talked about this a little bit last unit when we were reviewing pre-algebra. When we're talking about slope-intercept form, we're talking y equals mx plus or minus b. I sometimes will put the plus or minus sign here because that can be a positive or a negative number, and that is your y-intercept. When we're graphing, that is where we're going to start. That is my starting point. In story problems, that could be the starting distance. That could be the starting amount in a savings account. Different things like that. We worked with a couple units ago or a couple lessons ago, m means the slope, the rise over the run, the change in y over the change in x, unit rate. It means all of those things. When we're graphing, we will have positive lines, negative lines, zero slope, infinite or undefined slope. So I'm just going to graph a random line. This point right here is your y-intercept. It is the ordered pair 0, b. I write with capital B's because lowercase b's turn into the number 6 when I write. It really is a lowercase b, but I use capital because mine turn to 6's. So we're going to write the equation of the line. If those are the directions and nothing further than that, because we talked about standard form, they're asking us to write in slope-intercept form. If the slope is 1/4 and the y-intercept is -6, y equals 1/4 x minus 6. Do not write plus -6. Too many signs creates confusion. -6, put a -6. Now they're asking us to write the equation of the line. Again, if that is what you hear, they're looking for y equals mx plus b, plus or minus. Well, pretty straightforward. When I look at the graph, I can identify, I know that doesn't show up real well for you, my y-intercept immediately. B, or the y-intercept, is -3. Now I need to calculate the slope. I am given 2 points. I am given the point 0, -3, the y-intercept, and the point 2, 1. Using what I learned a little bit ago, I will use the change in y over the change in x. So I'm going to do y minus y over x minus x. -4 over -2. I can simplify that to +2. My slope is 2. My y-intercept is here at -3. So y equals 2x minus 3. Remember, we're not going to put plus -3. That is not necessary. Okay, we have another example. Y equals 0.5x minus 7. They're asking us to graph. Again, I did not give you a grid, so we're going to do our best estimating. -7 is my y-intercept, and that's where I'm going to begin. So I would move down to -7. We talked about that is really the point 0, -7. Now, I do not know how to graph decimals at all. I can't estimate, so I'm going to convert 0.5 into a fraction, so that would equal 1/2. I can graph fractions very, very easily. when we're graphing a fraction, we talked about slope means the rise over the run. Rise tells me the up and down. The run will tell me the left or right. This is positive, so I'm going to move up 1 and run 2. So up 1, run 2. I'll go up 1, run 2. Up 1, run 2. We are not playing connect the dots, so we're going to draw the line that extends through and beyond the given points. Now for the next ones, we have a couple choices. What form did I present you here? I gave you standard form. I like graphing really from slope-intercept form because it has all the data I need right there. So I'm going to rewrite this into slope-intercept form. I would minus 5x minus 5x. 4y equals negative 5x plus 8. I don't want 4 y's. I need to know what 1 y equals. So I will divide by 4, divide by 4. Y equals negative 5 fourths x. Not going to change it to a proper fraction. I'm going to leave it just like that. So I have a rise and a run. Don't want a decimal. Can't graph that accurately. So I divided this way. Now I divide here. I end with a positive 2. I'm going to just sketch my graph. My y-intercept is the point 0, positive 2. So I would start at the origin, move up to where approximately that would be. My slope is negative 5 fourths, so I'm going to move down because it's negative, and I always run to the right. So I'm going to move down 5, right 4. So I went down 5. Ooh, did I draw that out of proportion? But that's okay. That is what I got. Okay, a story problem. This is a little tricky. We need to just think about this. The ideal maximum heart rate for a 25-year-old who is exercising to burn fat is 117 beats per minute. For every 5 years older than 25, the ideal rate drops 3 beats per minute. Write a linear equation to find the ideal heart rate for anyone over 25 years old who is exercising to burn fat. Okay, we need to write the equation in y equals mx plus or minus b. Well, what do we know by just reading the story problem? What is the starting point? What information do we get that tells us where we're starting? Right here. That is where we're going to start. RB, the starting point, is 117. Okay, now the next part I want you to think about. For every 5 years older than 25, the ideal rate drops 3 beats per minute. I would like you to pause the video. I want you to think, if you're near someone, great, discuss quietly. What would my unit rate be here for that highlighted sentence? Pause the video. What is the rate of change? Thank you for pausing. Okay, a few things that I have mentioned in a video or two. When we're talking about slope, we talk about the change in y or the change in x. Okay, now we talk about x's They are the independent variable. They are things we cannot control. And when I think of things I cannot control, I can never control time. An hour is an hour, a day is a day, a week is a week. That's it. That is something I can't control. So when I read this story problem, what I hear is for every 5 years older, so when the person changes every 5 years, what is it asking the heart rates to do? The heart rate will drop. Oh, drop. Do you think that will be positive or will that be negative? We're going to drop heart rates 3 beats per minute. If it's dropping, it will be a negative. My equation would be y equals negative 3/5 x plus 117. Dropping 3 beats every 5 years, starting at the age of 25 at 117 beats per minute. If I asked you to graph this situation, we would only need a quadrant 1 graph because time would go here in years, independent variable, and you can only have positive time, so I don't need any of the negatives. Total heartbeats. Can't have negative heartbeats, so I don't need the negative y's. I know where I'm going to start at the point 0,117, and it would go down. Now, I do realize eventually in real life it's going to plateau because you can't go down till 0 because you're dead. What I would like you to do, because it's a longer video than I anticipated, I want you to pause the video and solve these 4 and compare answers to me. To be clear, this is really 2 problems. Graph this one, sketch a graph of this one, similar to how we did it up here. Pause the video and I will show you my answers. Thank you for pausing the video. I believe the first one was very straightforward. You just fill in negative 1/3 for m plus 3 for x. For the second one, I know this is my y-intercept, so b will be 4. I did the change in y over the change in x. It does not matter where you write the negative sign. Negative 7/5 x plus 4. Here I changed this standard form, even though it's not written appropriately, into slope-intercept form. Started at 1, went down 5, right 2, down 5, right 2 if I had real graph paper. This one started at plus 2, went down 2, right 3, down 2, right 3. Why do I move down? Because my slopes are negative. So I move down negative, my rise needs to decrease, and I run to the right. I divided everything by negative 2 to end with slope-intercept form of negative 3x plus 2, down 3, right 2, etc.